Part D is about the speed. So what was the difference between speed and velocity? In speed, we don't have directions. Just with the absolute value of the velocity will give us the speed. So in this part, we are going to discuss, going to see whether our speed is increasing or decreasing. To find it out, we need acceleration. If the sign of acceleration and the velocity are same during some time interval, it means that it can be both positive or both negative. Means that your speed is increasing. If you're between some time intervals, your velocity and acceleration have different signs, that it means that your speed is decreasing. Let's see in practice. For example, from your book, question number 5, the man is throwing the ball. What's he throwing? A jetty to the water below. So it takes k seconds for the device to reach the water. Okay, he's throwing. So let's be hand, so he's throwing, it's some reach to the highest point. So from the equation, you can see it's a quadratic equation, and it follows the parabolic trace. So what we are going to do first is find k. So what's k means? When this device will reach the water. So as it parabola, the reaching the water is finding the t-intercepts. If we go with the x and y, x-intercepts when it cuts the x-axis as it quadratic. So to do that, we can use our calculator, or you can use by hand quadratic formula. So I have the calculator here, so I just input the numbers, minus 4.9 and 4.9 and 8. So if you go to the solve, let's go. So 8. Now we can see there are two results. Of course, quadratic equation will have two results: 1.87 and minus 0.87. So negativity time cannot be negative for us, so we only choose 1.87. So k equals to 1.87. And there was 2, right? Okay, let's write all of them. Draw a sign diagram for the device velocity and acceleration function. So let's find the velocity. The velocity of this function will be minus 9.8 t plus 4.9, and for the acceleration we have only negative minus 9.8. So if you draw the sign diagram, so for the velocity we start from 0 and the halfway is 1.2, and it doesn't go to infinity, it stops somewhere, right? As it reaches the water, so this time till 1.872. So for this, the first sign will be this part will be negative, and this part will be positive. Then what else we need? Okay, for the acceleration, as you may see, it's for the velocity. Acceleration, it's always for any time. Why I put 8 here, I don't know. For the acceleration, it's always negative. Okay, 1.872 till reach the water for the acceleration. And we did it. Now, part C, what do they say? Was the speed of the device increasing or decreasing after 0.2 seconds? After 0. Okay, this 0.5. After 0.2 seconds, okay, after 2.0, it's a positive, but acceleration is negative, so it's different sign, decreasing for the first one. And after 1 second, the velocity is negative, acceleration is always negative, so it's increasing.